Hello, my name is Jeff and thank you for joining me today in this video where I will be discussing installing a backup generator to your house. The information contained in this video should not be considered that of a licensed and qualified electrician. It is also not a substitute for your own detailed review of the National Electric Code. Any details considering your specific installation should be directed towards a licensed and qualified electrician. Let's go over the generator first. The basic need of the generator is that the running wattage needs to match what you hook to it. To find this out, you can either look at the label plates of what you deem critical that you want powered by the generator, or you can plug those into a watt meter that you can buy at any of the big box stores or Harbor Freight, and it'll tell you what the running wattage is of the equipment. Once you've added up all those running wattage, you need to make sure that it is not greater than the label plate of the running wattage on the generator. Great news is you get to choose what's critical. In my house, what's critical is the internet, but maybe in your house you have a well pump to supply water to your family, so that's entirely up to you. The other requirement is that we need to install this in a floating neutral capacity, and that's a requirement that comes from the National Electric Code 250.30 and 250.34 Charlie. And what that means is if your transfer switch doesn't switch the neutral leg of your generator, then the neutral and ground bonding that is going to occur in the system is going to occur at the service panel entrance, and only at the service panel entrance. It cannot occur also in the generator. And that's typically how portable generators are wired. The neutral and ground lugs are bonded in the generator because they assume you're using it for a drill out at a construction site. But when you're using it as a backup generator and your transfer switch does not switch the neutral, which ours does not, it must be wired as a floating neutral. Let's go over how to check that with a voltmeter. Another way you can check it is by looking at the manual for the generator. It should tell you how to convert from bonding the neutral to a floating neutral capacity. I'm going to show you how to check it with the voltmeter just in case your manual doesn't go over that. Okay, to measure that our generator has both the ground terminal grounded to the chassis of the generator and also it's floating neutral, we're going to do some continuity checks. We have a voltmeter set in the ohms position with a it also has a buzzer that will beep when it has continuity. So as you can see here, when I touch these two terminals, we have a beeping sound. So the first thing we'll do is we'll go to the ground leg into the gas tank mounting screw and make sure we have continuity. You can see from the meter, well, you can't see the meter, but it says that it was 0 ohms and that the beeping sound also indicates that it was low resistance. Now we need to make sure it's floating neutral. So this has a tamper resistant plug to keep little kids like me from putting paper clips in it, but we'll see if we can get this meter in there. Yep, okay. Now we got the meter, and I can see through the connector that we are attached to the electrical connection past the tamper resistant part. So we have one lead to the neutral conductor, which is the tallest of the two conductors on the outlet. The other lead we're going to put into the ground connection. And you can see there that we don't have continuity. So that means this generator is configured for floating neutral. I already knew it was going to be like this because the manual says when attaching to your house you may need to configure it in floating neutral, and it shows you how to go into the generator and change that. I'm not going to go into that on this generator because your generator is definitely going to be different than this one. Alright, the next component of our system is a means of disconnect. We have to be able to attach the generator to the house, and National Electric Code 445.18 discusses that you're allowed to use a cord and plug as your means of disconnect. If your generator was hardwired into the house, that'd be a different set of rules and you would need a switch, and we're not going to get into that because we're going to show you how we installed it in this house. In this house, we're using a cord and plug. Now, a standard generator extension cord is going to have male on one end and female on the other end. Now you may have heard or even done yourself, made your own cord where it was male on both ends because it was easier to buy the parts. Well, here's a scenario for you. You're working with your son, you've watched him hook up your generator 100 times, and you feel real confident he can do it safely. So then it comes that point, PG&E shuts the power off in California, and your son's like, Daddy, can I go hook up the generator? And you say, sure, son. So it goes out there, he's all excited, he's not thinking right. He starts the generator first, plugs this into the generator, and now the other end, because it's male, you have live terminals, and he gets electrocuted and kills himself. And that's going to be on you. So always use the proper cord, male on one end, female on the other end. Now the generator receptacles for sale at any common big box store is going to have male connections on it to receive the female end of your generator extension cord. Now these will never be live. They look scary, but they'll never be live because the transfer switch that we've installed prevents these from ever being live with street power. The next part of our system is the wiring between the receptacle and the transfer switch. We've used 10 gauge, 3 conductor plus ground Romex cabling for this installation. It also goes by the term NM wiring, which means non-metallic or non-metallic sheathed cabling. The requirements for that come from 240.4 Delta 7, which states for 30 amp service to use 10 gauge non-metallic sheathed cabling. That cabling must be secured in accordance with 334.30, which means a staple within 12 inches of the box in every 4.5 feet. You can see here that this first staple is probably looks a little more than 12 inches to me. And then as we go along this cable, you can see that it's probably a little more than 4.5 feet. Now when you call for an inspection, basically what they look for is that the cable looks like it's secured and out of the way. But you can see how this cable is sagging down below the floor joists. So right away, that's how they're gonna know you're not within 4.5 feet. The next part of our system is the transfer switch. What we've installed in place of a traditional transfer switch is a generator interlocking device. What this device does is it keeps you from turning on your generator feed breaker while the main breaker is on. In order to turn the generator feed breaker on, we'd have to turn the main breaker off, slide this device out of the way, and then we could turn on our generator feed breaker. This keeps you from tying your generator in with the street power. These devices are available from several places. To name a few would be interlockkit.com and geninterlock.com. Also, the manufacturers of breaker panels like General Electric also make interlocking devices. Inside the panel, we've arranged our generator breaker to be adjacent to the main service disconnect. This is our generator breaker. This is the main service disconnect. This requirement comes from the interlock directions that came with our interlock. Those directions will also tell you how to mount the interlock to your main service panel. So consult those directions on the location of your generator breaker because it may be different than mine. Now earlier I discussed how we installed our generator in it had to be floating neutral. This requirement comes from the fact that this is a non-separately derived system. The NEC defines a non-separately derived system as your alternate power source does not have a switch to neutral in your transfer gear. Well, our transfer gear is an interlock device and a 220 breaker. And as you can see, where our neutral wire comes in, which is white, it goes straight to the neutral bus bar. There's no switch involved in that at all. So because it's not switched over to the generator's neutral, all the neutrals are tied together in the whole system, and that tie together occurs here in the main service panel. That means we have a non-separately derived system, and therefore our generator must have a floating neutral. Now the other requirement that forces you to do that is your neutral and ground are only allowed, which neutral is typically the white and ground is the bare copper, are only allowed to be bonded in the main service panel entrance and in that location only. So if they're bonded here, they're not allowed to be bonded at the generator. One more thing worth mentioning is you may notice a ground terminal on your generator. This ground terminal does not need to be attached to a grounding electrode or anything else. We've already checked with the meter that the ground on our receptacles is attached to the chassis of the generator, and that is going to transfer that ground through the cord and plug and Romex to the grounding electrode system of your house, which is bonded in the main service panel. Adding a grounding electrode isn't prohibited, and if you do it, you're opening yourself up to a whole nother slew of requirements to make that part of your house's grounding electrode system. So my recommendation would be to not install that rod. It is not needed specifically in Article 250.